This is problem number 24 from the 2006 AMC8. And this is one of those problems where you're essentially given a multiplication problem but without any of the numbers, and you're supposed to be able to use logic to find something out about them. And this one is particularly interesting because it turns out in the end that you can't find out what CD is. CD actually could be any two numbers based on the way this problem's worked. And there really are three ways you could have done it. The quickest way is to know an important multiplication fact, and that is if you multiply any number times 101, like 23 for instance. If you multiply 23 by 101, you end up with 23. And so multiplying 101 by 23 gets you exactly what the answer is on this problem, and so very quickly you can see that a plus b equals 1. This fact can continues to be applied. If you do 1001 and put it times 234 and you do your multiplication, you end up with a problem that looks just like this, and you end up with 234. And this is a nice important multiplication trick, where if you multiply by 101, a two-digit number by 101, a three-digit number by 1001, and a four-digit number by 10,001, and so on and so forth, the same pattern continues. So that would have been an easy way to do it. Another easy way to do this would be to turn this problem on its side, and instead of doing it as a multiplication problem, do it as a division problem, which says if this is a true statement, then CD, when divided into CD will give you ABA. And if you notice this, CD, even though it's like a two-digit number, a two-digit number goes into it itself exactly one time. And so when you do that, you now have 0, and you bring down your C here, which is a one-digit number, so CD can't go into it, so this must be a 0, and then you bring down your D, and CD does go into CD to get 101. So ABA has to be 101. And then finally you could go through and realize that there's only a couple ways that you can accomplish this, where you have a D here and a D here, and the best way to do it is to put a 1 in for A, and then basically you could try anything in here for 3, and you get 1 times 3 to get 3, and then if you carry through, you would get the next if you're kind of actually doing your problem here, so it'd be 1B1 and C3, just because I'm guessing 3, I would get 3, and then this 3B, which I don't know what that is yet, and 3, and then I would get C, and then CB and C, and I realize that the only way to get C3, which is what I would get, is that if 3B is 0, which means B must be 0, and then this must be 0, and I realize C could be whatever it wants because ABA is 101. So it's an interesting multiplication problem, all based upon these important facts about how when you multiply things by 101.